Hello, pre-algebra students. This lesson video is going to be about unit rate. It is also our last lesson in this first unit. So get excited because you're about to finish your first unit. Just like in class, I'm going to have you start with these two warm-up questions. Go ahead, pause this video and think through these questions first because it's going to be really important for the topic of this lesson. You are answering this question, which is a better deal? And there's two situations I'm having you think about. Go ahead, pause the video, and then come back to hear what you might have been thinking about. So the question in the warm-up that we're talking through is this idea of which is a better deal. And when you're talking about shopping, in class I'll ask what this means, and a lot of times I get the answer of spending the least amount of money for the most amount of food. And so for this first situation, which is a better deal, buying 2 candy bars for $5 or 3 candy bars for $6? It's hard to compare those right now because we're getting different amounts of food. But there's a way to do some calculations to help us compare and figure out what's going to be the better deal. Instead of knowing the price of 2 candy bars or the price of 3 candy bars, if I knew how much each candy bar cost, that would help me do a better job of comparing them. And so what we are going to do is take this information and find the price per candy bar. In order to do that, what math are we going to need? Hopefully you are at home saying division. We want to find the price per candy bar. That means I want to take the price of $5, and divide by how many candy bars we're getting for that. So for this first one, it would be 5 divided by 2, which works out to be $2.50 per bar. For that second situation, I'm going to do the same thing. I want to know the price per candy bar, not candy car, candy bar. So I'm going to be doing the same type of math. I'm just using different numbers. Here, the price we're given is $6, but that $6 is for 3 candy bars. So $6 for 3 candy bars means each candy bar is worth $2. I can say it's $2 per bar. When we talk about what is the better deal, when you're getting a deal, usually it means you're getting more food for less money. And so in this situation, which is the better deal? Our better deal, we're going to say, is the second option. The second option, each one of those candy bars is 50 cents less than this first option here. Now, I know when you're shopping, there are lots of things you have to think through. I've had people say, well, like maybe I just don't have $6 to spend. Maybe I only have $5 to spend. That's what I'm going to do. And that's a very valid shopping experience, right? But when we talk about better deal, this is what we're describing is it's a deal to pay $2 per candy bar instead of paying $2.50 per candy bar. This strategy of finding a price that's easier to compare, like the price for each candy bar, is going to be something we see throughout this lesson. And it's also what we're going to see down here for the second part of this warm-up. We can do something really similar for this peanut butter here. Here, both of these are jars of peanut butter, but we've got different sizes. Instead of talking about the price per candy bar, here, it's not a number of peanut butter jars we're getting. Here it's different amounts. This first jar is 35 ounces. The second jar is 16 ounces. So instead of price per candy bar, I'm going to be looking at the price per ounce. So for this first one here, if I want to find the price per ounce, I'm going to be doing all the same math we did at the top, just with numbers that are maybe a little more fun. My price that I'm working with is $5.79, and we are spending that on 35 ounces of peanut butter. I will say with some of these prices, like this is real life prices here, some of these division problems are going to get a little crazy. Feel free to grab your calculators on this one instead of doing this very fun long division problem. When you do that division, it works out to be about 0.17 cents per ounce of peanut butter. So that means each ounce of peanut butter, an ounce is just like an amount of peanut butter, right? Each ounce of peanut butter costs 17 cents. Again, we can do something similar for our second option. Again, I'm looking at the same thing. I want to look at price per ounce. Notice I keep writing these words out. I'm writing those words because that really helps me figure out the order my division is going to be. If I want price per ounce, it means I'm taking my price, the $2.49, and I'm dividing that by the ounces. If you do that division differently in a different order, you get a different number. So my price per ounce, I've got $2.49 that I'm dividing by 16, and that works out to be about 16 cents per, look, my face is in the way, per ounce. So similar question as above, which one is the better deal? Which peanut butter should I buy? If the only thing I'm caring about when I go shopping is the better deal, the one I should buy here would be our second option. That second option there, I'm spending just a little less money for each ounce of peanut butter. It's only a penny difference, but remember that's a penny for each ounce of peanut butter. So if you buy a ton of peanut butter during a year, those pennies add up. This idea of finding the price per candy bar, or the price per ounce, is going to be what this lesson is all about. What we were finding in both of these problems is something called unit rate. And we are going to define that in a moment. But what I want us to do is really focus in on what this lesson is all about. So I'm going to take us back here. The focus of this lesson is going to be how we can use this thing called unit rate to help us compare, specifically to compare ratios. This lesson is building on what we learned yesterday about ratios. Looking at these two problems we just did, there's ratios everywhere. We've got 2 candy bars for $5, 16 ounces of peanut butter for $2.49. These are all ratios. But in order to compare these ratios, I had to do some math first, and that math was finding something called unit rates. Our definition of unit rate is right here. Unit rate is just a special type of ratio. Yesterday we said ratios compare two numbers. So ratios are things like comparing 2 candy bars to $5. But a unit rate is a special ratio that compares an amount of something to 1 unit. And when we say 1 unit, that means it could be one of anything. For example, we could say, maybe I go to Papa John's and I see pizzas cost $12 per pizza. That's a ratio. I'm just saying it's $12 for every 1 pizza. That's our ratio there. And that is a unit rate because we are just talking about 1 pizza. We could also see stuff like this with speed limit signs. When you're driving and you see the speed limit says 45 miles per hour, that is a ratio because you're talking about how many miles you can go in a number of hours. But specifically, speed limits are saying you can go 45 miles in 1 hour. That is a unit rate because it's got that 1 again. Unit rate is something, if you know what a unit rate is, you're going to see it everywhere. I have a picture below of where you can see it in the store. When you're looking at prices, usually if you're, lots of times when I'm shopping, this is the one I'm looking at, right? Like that's the price of the object. So this picture here, I've got this large yogurt cost $1.62. The smaller yogurt costs 72 cents. And that's usually what I'm focused in on. But if I'm trying to compare and trying to figure out what's the better deal, which one should I buy, there's also in a corner of that price tag lots of times something labeled unit price. That's that unit rate that we were just calculating for the peanut butter. This larger yogurt here, yes, it costs more, but if you break it down, each ounce of that yogurt costs 5 cents. Means you're paying 5 cents for every ounce of yogurt in that large container. And with the smaller one, yeah, it costs less, but you're paying more money for the same amount of food. You're paying 12 cents for each ounce of yogurt. So if you don't really care how your yogurt is packaged, if you want a lot of yogurt, it doesn't make sense to get a bunch of these small ones because you're paying a lot of money for each ounce. Instead, it might make more sense to just get one big one because you're saving a lot of money if you do that. So you can use those unit price numbers on the price tags at stores to help you make decisions when you're trying to compare options. Lots of times when you look at them, you're going to see something that's a larger quantity, like this large yogurt has a lower unit price than the smaller ones, which can be a strategy if you eat a lot of yogurt or whatever the food is. Now, this is just one example of unit rate. One example of where you can see unit rate is with prices. So for example, this one about the yogurt, but also what we just did with the candy bars or peanut butter. But there are so many other places you can see unit rate. So the rest of this lesson is going to be other situations where we can calculate unit rate and why knowing the unit rate can be helpful for us. So moving us on to the next situation. In this story here, we are given information about motorcycles, and the question we are going to be talking about is gas efficiency. Go ahead, pause this for a moment to read through this information. I would also suggest looking over the table and the graph a little bit so you can familiarize yourself with it, and then come back to hear us talk through this question. So in this story, it tells us that Carlos is buying a new motorcycle and he's comparing these two motorcycles. This first one is called the sports motorcycle. The second one is called the leisure motorcycle. Again, when you're shopping for things, there's, I'm sure, a lot of different things you are considering, but it says here that in this situation, Carlos wants to compare the gas efficiency for each motorcycle to help him make that decision. In order to answer this question, we need to know what they mean by gas efficiency. Gas efficiency. Well, efficient is when you're using something responsibly or not using a lot of it. Gas efficiency is all about saving gas, right? If you are buying a car or a motorcycle or any vehicle, it benefits us if that vehicle or car or motorcycle doesn't need a lot of gas to go really far. Gas efficiency is all about these two things. It's the two things I see in the table and on the graph. It's all about how much gallons of gas you use and how many miles you go. If you've ever bought a car or a motorcycle or any sort of vehicle, you might hear the phrase miles per gallon. When we talk about gas efficiency, this is how we measure how efficient a vehicle is the miles per gallon. We want to know how many miles does that vehicle go for each gallon or per gallon. This is also the phrase that's going to help me figure out how I'm going to compare these two options. This is the unit rate we are going to be calculating. For our sports motorcycle, I'm given a table. If I look at the table is telling me these two pieces of information. It's giving me different examples of how many gallons of gas Carlos could put in the motorcycle and how many miles that motorcycle might go. If I want to know for this motorcycle the miles per gallon, it means I don't want to know how many miles he can go for 5 or 10 or 15 or 20 gallons. Miles per gallon means we are talking about only 1 gallon of gas. And so to calculate the miles per gallon, do you know what we're going to do? I want to know the miles per gallon for this first motorcycle means I'm going to be doing more division, just like we did above. I'm going to take the number of miles he can go and divide by how many gallons it's using. Now notice this table, we've got 1, 2, 3, 4 pairs of numbers. It does not matter which pair of numbers you use, we just need to do division once. So go ahead, pause this video, see if you can figure out what the miles per gallon for this first motorcycle is. You've got 4 different options of how you could do this. Maybe you used the first pair of numbers and you said 287.5 miles divided by those 5 gallons of gas. Remember, I'm using the order of these words to help me decide the order of my division. If you do that division problem, it would give you 57.5. But you could have used any of these, right? You could have also done 575 miles divided by 10 gallons of gas. That also would have given you the same thing. You could have done 862.5 miles divided by 15 gallons of gas. It would have given you the same thing. I think you get the idea. You had lots of options, but one of these is what you would need to do to find our miles per gallon. Now that 57.5, what does that mean? Well, it means that the sports motorcycle can go, and I'm going to put this in words to help me remember. It can go 57.5 miles per gallon, or you can even say gallon of gas, right? That means if he only has 1 gallon of gas in that motorcycle, it's going 57.5 miles. We're trying to compare these two options. So this is not enough information. I also need to know what the leisure motorcycle's gas efficiency is. So I'm going to have to do the same thing over here for this leisure motorcycle. Now notice, instead of a table, for the second option, we have a graph. But the graph is communicating the same exact information. If I look at the graph, I've got the graph of this line here, and on that line are a bunch of points. Each point represents 2 numbers, remember? And those 2 numbers tell me something similar to this table. For example, if I pick this point right here, those 2 numbers are saying 8, and then make sure you always read your label, 8 gallons of gas will get him 440 miles. It will take him that far. Now, you didn't have to use this point. You can use any point on this line, but I'm going to have you go ahead and do the same thing. Can you find for the second motorcycle, the leisure motorcycle, can you find what the miles per gallon are? Go ahead, pause the video and try that now. Well, if I use this point that I had chosen for us earlier, you didn't have to, but I'm going to since it's already marked. I'm taking my miles divided by the number of gallons, and when I do that, it gives me 55. So that means the second motorcycle can go 55 miles per gallon. Once we have this information, I'm using unit rate now, and it's going to help me answer our question of which one is more gas efficient and by how much. We have figured out the sports motorcycle gets 57.5 miles per gallon. The leisure motorcycle gets 55 miles per gallon. Which one would you want to go with? Now, sometimes people say the leisure motorcycle because it's the smallest number. Sometimes people say the sports motorcycle because it's the biggest number. Earlier, when we were talking about price and spending money, we obviously want the smaller number, right? You want the cheaper item. That's how you get a good deal. Here, with gas efficiency, think about what this means. Would you rather go more miles with 1 gallon of gas or less miles with 1 gallon of gas? Well, I'd rather go more miles. If I can go more miles with 1 gallon of gas, it means I have to go to the gas station less and I save money. Here, in this situation, a bigger number is more gas efficient. A bigger number is what we want because it means you get more miles from that 1 gallon. So, based on gas efficiency, which motorcycle is more gas efficient? It is going to be the sports motorcycle. The sports motorcycle can go 57.5 miles. The leisure motorcycle can only go 55 miles with 1 gallon of gas. There's a second part to this question. It says, and by how much? So how much more efficient is the sports motorcycle? It's like I'm asking for the difference in these numbers. We would need to subtract, and that would give us 2.5 miles per gallon. So I'm going to say the sports motorcycle is 2.5 miles per gallon more efficient than the leisure motorcycle. It doesn't have to be exactly like that, but we're looking for that we choose the sports motorcycle and we're looking for that 2.5 in there. This is another example of where you might see unit rates. It's not just money and prices of things, but you can also see it in situations like this. Again, the idea of being able to find unit rate is, why was it helpful? Well, it helped us compare these two options. When I'm looking at these huge numbers or a graph like this, it's a lot harder for me to compare those. But once we had those two numbers, the 57.5 and the 55, made it a lot easier to compare the two. There is one other example of unit rate that's really common that we're going to talk about, and that last example is speed. Before we jump into some of the problems, the question I want to ask you are, what are different ways you can measure speed? For example, if you are in a science class, lots of times you talk about speed in meters per second. But I would argue in my life that is not the most common way I am measuring my speed. So think about what are other ways you can measure speed. It's not always meters per second. In class, when I ask this question, I'll get a lot of answers. The one that comes to my mind immediately is when I'm driving, I might measure my car speed in miles per hour. We mentioned speed limits earlier, and we said speed limit of like 45 miles per hour. Miles per hour is an example of how you can measure speed. Now, the US does miles per hour, but not all countries do miles per hour. A lot more countries do kilometers per hour. And these are not all of the different ways you can measure speed. There are plenty of other speeds. You can measure something in feet per minute. You can measure things in kilometers per second. But I wanted to come up with a list of a couple examples to show, when we get to the second question, that there is something that all of these have in common. First, a lot of people immediately notice when you're talking about speed, we're always using that word per. Every single time when I was talking about speed, you don't just say speed is miles. It was miles per hour or meters per second. When you describe speed, it always is going to have that word per in it. The other thing I want to look at is what comes before and after that word per. So when we look at all of these things that came before it, meters, miles, feet, kilometers, what are those all examples of? We use all of these to measure a type of thing. You use meters, miles, kilometers, feet, inches, yards. You use all of these to measure a distance. When we're talking about speed, it always starts with a distance. And then the second part, when you look at what all of these words are, second, hours, minutes, what are all of those describing? Those are all examples of how you measure time. When you are describing speed, speed is going a distance over time. And so when we calculate a speed of something, those are the two things you have to know. If I ask you, how fast am I running? If you wanted to calculate that, you would need to know, well, how far did you run? How long did it take you to run? You would need to know my distance and my time. Speed, though, is the last example we're going to look at unit rate. And it's an example of unit rate. It goes back to what we said about speed limits, right? Miles per hour is a unit rate because we are talking about how many miles you go per 1 hour. It's all about that magic number 1. And even if I change the way we measure speed, even if we're talking about meters per second, it's the same idea. It's how many meters you go per 1 second. It still has that 1 in there. These words, distance per time, is what I would probably put in my notes. The examples aren't as important, but distance per time is that recipe, that formula that's always going to help us calculate speed. So for example, if I asked you who walks at a faster rate, someone who walks 60 feet in 10 seconds or someone who walks 42 feet in 6 seconds, right now, it's too hard to compare those. I don't know who's going faster. What do we need to do? We need to find their rate, specifically their unit rate. And to do that, we are going to use this right here. We are going to use that formula for how you find speed. I think you can do this. So I encourage you to pause the video now, see if you can figure out who is moving faster in the situation. Once you've got an answer, come back and check and see how you did. In this situation here, I've got 2 people. My first person's going 60 feet in 10 seconds. To find their speed, I'm taking that distance, and just like we've been doing all day, taking that distance and dividing. Specifically here, the distance divided by time. So for my first person, if they're going 60 feet in 10 seconds, that means they went 6. What words come after the 6? Or they're going 6, we're measuring feet. They're going 6 feet in 1 second. So we're going to say 6 feet per second. That is their speed. I can do the same thing for my second person. I'm going to find their speed. I'm going to take their distance and divide it by their time. So for my second person, they went 42 feet. It took them 6 seconds to do that, which means what's their speed? Their speed is 7. 7, we're measuring in feet. So 7 feet per second again. Once we've got this, I bet you it's so much easier now for you to figure out who is moving faster, which is a faster speed, 6 feet per second or 7 feet per second. Our faster speed is going to be that second person. When you're talking about speed, a bigger number means they're moving faster. This is our last example of how we can use unit rate to help us compare. Even me as a math teacher, I'm looking at this information. It's too hard for me to figure out until I do that division, and then it makes it a lot easier. I want to give you a chance to practice with some unit rate. So I've got this question here. It looks a lot like that motorcycle one now, doesn't it? But it's about different information. So the story is up here, their information is here, and the question's down here at the bottom. We're asked, at what rate does each biker travel? Go ahead, pause this video one last time, and then come back to check and see how you are doing. All right, hopefully you got an answer. I put some stuff up here just to get us started. Because we are being asked at what rate does each biker travel, that is code for we are looking for their speed. So once again, I'm looking at their distance over time. Distance over time or distance per time isn't something you have to memorize. For me, I just think of an example. I just think of miles per hour and then remember, okay, miles is my distance, hours is my time, and use that to help me remember the order. You don't have to memorize it if you have an example you can use. So for each of these, just like what we saw with the motorcycle, there's a lot of different ways you can come up with their speed. Now, I will say for Brian, our table starts with 0, 0, which maybe seems a little silly, but it is true. If he does not bike at all, if he bikes 0 hours, he is going 0 miles. But I'm not going to be able to use that to find his speed. His speed is not 0. So I would have to use one of these two. It doesn't matter which one you do. I prefer the smaller numbers. So I'm going to take his distance and divide it by time. And if you do that, we get 25. What does that tell me about Brian? 25 is a speed. So I'm going to say he is biking 25 miles per hour. MPH, maybe you've seen it before, means miles per hour. For Shanice, we could do the same thing. Now I've got a graph for her. If I look at her graph here, I'm going to pick a point that's easy for me to read. This one here is in the middle, so maybe it's harder for me to know what number that is. So I'm going to pick this one, and that tells me after 2 hours, she has gone 30 miles. So her distance is 30, her time is 2, and she must be going 15 miles per hour. So if I want to know how fast each of them are, if I want to know the rate of each biker, Brian is biking 25 miles per hour and Shanice is biking 15 miles per hour. For that explain, I know we all see the word explain and say, oh no, she's making me write something. But remember, you can always write the equation. You can always write 75 divided by 3 equals 25 and 30 divided by 2 equals 15. That is a perfect explanation. You can always explain in words or in math. There's one final part to this question down here that says, wait, there's one more biker. Sean recorded his speed in the table below. How does his speed compare to the other two? And I went ahead and I copied down the other two people for us. Looking at Sean's table, you may notice something different about it. Take a moment to look at it. When I compare his table, especially because we were given a table for Brian as well, I noticed something different. Brian's table was giving me the number of hours he biked and how many miles he went, but Sean's table is telling me how many miles he went, but how many minutes it took. The whole reason we want to know unit rate is because it helps us compare by making it the same. For example, when I say the same, Brian and Shanice, when we find their speed, it's making it the same amount of time. We're talking about 1 hour for both of them, which means I can't have Sean's table talking about minutes because then I'm trying to compare different things. I can't compare hours and minutes together. So if we want to compare these, first we really need to notice that it's got minutes instead of hours, because if we don't, that's going to mess with our answer. But more importantly, I need to make Sean's information the same as Brian and Shanice's, which means I want to compare Sean with them. I don't want to be thinking about minutes. I want to think about hours. So when I pick one of these pairs of numbers, when I go to find Sean's speed, I'm still thinking about his distance divided by the time, just like the other ones. But for his distance and time, for example, if I pick this one, I'm going to say 20 miles. But his time, I'm not going to say 60 minutes because I know 60 minutes is 1 hour. In order to get the speed so that I can compare with them, I need them all to be in hours. So I'm going to say 20 miles divided by 1 hour. That math's easy enough. 20 miles divided by 1 hour is just 20 miles per hour. You could have done that with any of these. 120 minutes would be 2 hours. 180 minutes is 3 hours. And if you do any of those division problems, you're getting that same speed of 20 miles per hour. I like this last one because it makes you think a little bit, but it's a good reminder that when we're looking at these, if you want to compare situations, you need that to be the same data, the same information. So here, that same information was we need them all to be in miles and hours. This is the end of our lesson on unit rates. The 3 unit rates we really focused on in this lesson were unit price, gas efficiency, and then this last part here about speed. And hopefully you're feeling a lot more confident about ratios and unit rates. Thanks so much for watching. Bye, y'all.